Everyone, welcome to my channel again. At this point, if you're viewing any of my videos, you're probably my TA, you're my professor, or quarantine has got you to some stuff that you should not be watching. But anyways, stay safe. COVID-19 has spread a lot. Uh, that's a bad thing. Anyways, let's get to the point. So as you can read, what we're going to do today is try and do my assignment 2, and this is part of my visualization CSE 564 at Stony Brook University. It's a good university, so check it out. Anyways, but yeah, so the data set that we took today is biggest blunder. That's the IEEE fraud CSI detection data set. As you can see, there are many columns in this data set. In fact, the number of columns itself can be a data set. Apart from that, yeah, these data set has around 5 lakh entries, which turns out to be okay. That's around 5 million rows. So I tried to cut it short because running with these number of rows, it was not possible. This is my application. The project says, first of all, implement random sampling. So this is the project. You guys can have a read. You can pause it. It says implement random sampling, remove 75% of the data, get k-means clustering, optimize it. So the first thing that you do is get the k-means clustering. Now, when I did this, I noticed the first thing that at k equal to 2 and k equal to 3 are the points that can be k equal to I'm so sorry, k equal to 2 and k equal to 4 can be considered as potential points for elbow points. So I took one of these points, and so yeah, once you are done with this first half, the second half says that you need to find intrinsic dimensionality of data using PCA and produce the scree plots for the same. So again, use that. I made scree plots for the data. So this is the first scree plot for all data, and as you can see, now the reason this looks very peculiar is because of the data set that I picked up. Most of the data is completely dependent on the fact that is it an is fraud or no. So like the data is completely dependent on that fact. So when you go, you can see the first component has around 0.99. As you can see, it progressively increases. I mean, the concept is right, but this example is probably not the best to demonstrate the same. But yeah, at the end you can see it adds up to 1. For random samples, you see a different value, but then as you keep going, again this adds up to close to 1. Stratified samples, same. If you keep going, and at the end it adds up to close to 1. Now the question is okay. Now the question is next thing. This was part of my PCA. I realized the intrinsic dimensionality is 1 itself. That's the one single dimension. If you want to see the data points that I took, here are the data points that I took out of the train. I took the 100,000 data points, and these were the attributes that I considered. Is fraud, as you can say, considers most. Transaction ID is something that I've skipped. It's not useful, but yeah, is fraud is the main principal component as it comes out. That's my code for it. Here's how I implemented WCSS. I used k-means. Yeah, so this is how it went, and this is the PCA component part of it. As you can see, stratified X. I've used random X. I've used all kind of fitting technique that had to be done. So yeah, um, this is my PCA stratified. Yeah, once we are done with this, the question says visualize using the top two components. So we use the top, as you can see, I use the top two components. And when you use it to scatter plot, scatter plot is something. See, this actually confirms our hypothesis of it being a single dimension. As you can see, all the points are linearly correlated. More or less, they are linearly correlated. Very few points are outside of this. So you can see there's a straight line here. This is precisely our hypothesis, that is exactly why 0.99 was seen here. This shows stratified. There is for random as well. Now, so yeah, with these we can confirm that. Now the next part of the question says implement MDS. So here's where it was a little tough for me. For the MDS implementation, uh, the processor was taking too long, and the fact that I'm because of COVID-19 I'm back in my hometown. I do not have the computer and the access to it, and it's taking a really long time to actually run this part. But in theory, again, you would do this, send it to the same functions, or you send it to the same function of scatter plot. uh, Here's the function for yeah, here's the function for scatter plot. You just send it again and it's going to do it. So yeah, in theory it works, but then took a lot of time to run. Approximately it took me approximately half an hour to run. So each refresh testing it out was not possible. So this is my demonstration for lab 2. I hope you enjoyed it. If you have any questions, you can email me. This is probably going to be my least scoring assignment, but it's the one where I learned the most and gave it all. So thanks a lot.